Quick word of caution before we begin. This power supply contains lethal voltages tested with specialized equipment. If you're not experienced in working on power supplies, I'd urge you strongly before getting into this unit. It's not worth dying over your swimming pool. Hey everyone, I added a half a bag of salt the previous day and noticed that my numbers had not gone up. I found that kind of strange until I looked up at my control panel for my pump. And yeah, not good news. And this is right after Hurricane Ian. I'll point out that I did have all of my power off during the hurricane, so it wasn't anything related to power surges. We didn't have any major power related issues. And I'll tell you, these are fed off the same power, so it's not an issue of a breaker being tripped. I'll just say that now. But I will cut power at this time to all my breakers as I get into the unit for safety purposes. Always shut off your power before working on the unit. And mine having the remote control only has the blank faceplate on the top of the pump, so I'm going to remove it now with the 2 Phillips screws. 3 more screws secure the inner cover of the control unit where the connections are. I remove those now. With the cover removed, we see the AC and remote connections. Now I reapply power for mains testing. And hooking up my multimeter set to AC volts, we're seeing 247, so we are getting the line voltage in as we're supposed to be. If not, I'll be troubleshooting this back towards the breaker box, but this is a pump issue. I'm going to set the meter to DC volts now, and I'm going to check the 12 volt in common on this RS485 connector, and what I see here is definitely not what I'm looking for. It looks like a low voltage fluctuating voltage. Definitely some sort of internal electronic failure going on here. I did fluctuate these dip switches back and forth a couple of times and retest to see if maybe it was some sort of switch oxidation issue causing it, but to no avail, the problem persisted. So mains power is shut down again. I'm going to loosen these terminals now and pull the cable. I can't just pull that black connector because I have to pull the cable through ultimately as the whole pump is being removed. This will be followed by the 2 AC connections and the ground. This ground has definitely seen better days. Grounds like this should definitely be cleaned up. The liquid tight connector is then loosened. Now clip the ends of these cables off to fit through. And with that, the AC power is removed. If you've been watching closely, you'll notice that this whole compartment is got water on the bottom of it. And I checked the liquid tight to see if it was coming in from there, from the distribution, and it is not. This is definitely something I did not want to find. So I put wire nuts on the AC power, just as a reminder. Anybody sees it knows this is AC power. A flathead screwdriver will loosen the earth ground lug. Then the earth ground can be pulled out, and that's the last cable. Pop off the basket cover. I sucked up a lot of stuff since after the hurricane, as we see. This causes a pressure drop in the filter, and the filter starts to drain down. Turning my dump valve also further introduces air into the system to drop water out of all of these systems. There are 2 plugs in the bottom of the pump that are removed to allow water to drain. And eventually it's emptied out. The pump itself is now ready for removal. This input fitting is turned to loosen, followed by the output fitting. A correctly installed pump need only slide right out unless it's secured to the ground, and then those bolts would first be removed. Easy. And I'll be sure to take the opportunity to clean up this area while the pump is removed. I have to bring this inside, so obviously I'm going to have to wash it. I just want to make sure that I don't get any water into the control panel area, which is currently open, so I'm being careful. Then I'll leave it in the sun to dry. This motor drive unit is Century 10004713-001-001. And I'm going to kick things off with the removal of the fan shroud. That's 4 screws. One was so rusty it broke off, so I only had to remove 3. So now I remove the shroud off that broken screw. And we can see there's some garbage that collects in there. That's why it makes some noise sometimes, the pump. if weeds grow in there, even if you cut the weeds, they get caught in these impellers. There's a lizard. So yeah, opening that up and cleaning that out could reduce noise that you get in this pump. And I'll point out that the motor feels like it's spinning very smoothly, no problems at all. If I felt binding on this motor, we'd be looking at issues on multiple fronts here. I had to stick a paper towel with needle nose pliers down this hole to get all the water out of that rusted bolt, and I really hope that bolt comes off without snapping. And here's what we're looking at after drying out. The control unit housing is screwed in with a T25 anti-tamper type bit, which I'm now pulling out of the unit. This is what that head looks like as removed. There are 4 of them holding it in. I use a big flathead leaning against the ground screw for leverage to jimmy the cover up and break the seal. And now I disconnect the upper control board. We'll put this piece out of the way for now. I forgot to mention this, so I'm going to throw this in now. Setting the voltmeter to DC, be sure to measure the voltage on these 3 filter caps. Any one of them will do. They're tied together, that there's no voltage. If there is, wait for this thing to bleed down. You grab onto that, it will knock you on your ass with 260 volts of weekend ruining misfortune. So that's my warning to you. Just looking at the condition of this aluminum, whatever water has been leaking in here for quite a while. This is not of recent origin with the oxidation that I'm seeing, but I'm going to dry this out to the best I can right now. I'm going to be real gentle with this middle screw that was rusted that I drained the water from before in the hopes that it will come out easily. When it first starts, you can never tell if the screw's turning or if you're just twisting the head right off the shaft of the screw. But it looks like we're lucky and the screw is turning and I'll be able to remove it safely. We'll put this one with the winds. 2 screws on the side also secure the drive unit just under the drive unit onto the body of the motor itself. I remove those now. And a T15 bit secures the board into the housing. All 5 of these screws are removed. Using a T10, I remove these 3 screws, which actually heatsink a couple of components on the bottom of the board to the enclosure itself. Capacitors and the coil have a plastic sheet, a barrier on top of them that connects them to a mastic-like material that makes it sticky to the actual housing, as well as the heatsink material for the ICs. It needs to be rocked back and forth to loosen it. Eventually, these components do come loose and we can see the board is free. However, it is held by a 4-pin connector right there in the middle forward section of the board right here. So I carefully push down on that connector as I lift the board to detach it from the board. There's no easy way to do it as you don't have direct access to the connector. Sticking the large flathead in between the connector and the pins and just giving a light twist to pry it right off made easy work of disconnecting it. Now lift the board up and out of the housing where we take our first look, and we could see where it was held in with that tape-looking material on the capacitors, the coil, and the heat sinks. And this is really bad because it looks like water got into the back compartment of the power supply, and we can still see water in there, the height of which from the white ash is telling. It's not good. Here's the 4 pins that were connected to that connector that go out to the motor. Connected to this IC, we have seen this before. Video on the top right, and we're gonna have to go through all these components we see here, but with the video that I just showed, the Pentair, everything here was potted, all the caps were potted, all the chips were potted. The Pentair is absolutely non-serviceable. Immediately though, we see the first problem. This capacitor right here, C6, has exploded, and I can't get a value off that cap because the top exploded. We could also see other artifacts on the board that show other possible traumas that happened. The light white splashing is probably when it was turned on its side during cleaning though. As it sits on the ground, it pitches angled to the left as shown, and no water made its way onto the left-hand side. The most logical conclusion is it made it from that front portion and then poured into the side. But why did it only pour into one side? It never made it as high as these ICs, and nothing here. This is where the coil sits, so it would be cantered in that direction. I'm just wondering why no water poured in on that side of the unit. Looking at this YouTube video I made in 2018 before I redesigned the whole pool pump and filter assembly, we could see that the pool pump does in fact canter to the other side, sitting on those blocks. But is it possible that water sat in there that long? I mean, I just don't see it. And I'm trying my best to wipe off these electrolyte and crystals and crud and whatnot from the top of this capacitor. Pull off that little metal piece, if only to get a reading off of this thing. But the can's completely blown out. That one piece I need to see is just not there anymore. I put a post on EEV blog about this, wondering if anybody has this board and knows what the value is, but I can't even read it off of there. Maybe there's an 8 on there, a 6, 8, I don't know. While cleaning it up, it snapped right off its mount, so I'm just going to clean up that C6 area, and we'll address that later. Yeah, this is just an unfortunate rupture for a non-documented item. The way things are looking, the further I get down this power supply troubleshooting without finding a problem, the less chance of success I'm going to find. But we're going to start from the beginning. We have these thermistors over here that we're going to check and make sure that they're okay. And I should read and open across them. I'm going to check my meter first. And now I'm going to go across each one. And this one is reading open as it should. And this one also reading open as it should. If I saw anything else there, then I would definitely have to address the issue right there at the beginning. And there's a bulb right here that looks like a spark arrestor or a lightning arrestor. And I'm going to check across that too. Should also read and open. And it does. There are also a couple of safety caps going across the AC, those big black boxes. I just want to read the ones that were going across the AC here. And I should read across some capacitors, the inductor, and onward to the rectifier. So a couple of mega ohms. And this is a tough test point. So we'll test from here. And we are getting a couple meg. Definitely not a short, so it's probably safe to proceed. And if you're asking yourself, why don't you just look at a replacement board from Hayward to figure out which capacitor broke and replace it? The answer is they do not sell you this board. They do not even sell you the rear module. You have to buy the entire motor and this module together, which only costs $200 less than the entire pump, which sucks. The other thing might seem like an issue for testing, which is it's 240 volts, but you don't need 240 volts for testing it. As I have found, I'm using AC from my Variac, and I'm just going to plug in line and neutral right into here as shown. And the reason why I do this stuff and I'm still alive is because I use an isolation transformer and a Variac. I don't plug this into line voltage and try and test it, or I'd be dead. Multimeter set for AC Variac is around 45 volts, and we're seeing, 40 volts. So Variac's not an exact science. But it looks like we're getting AC all the way to the rectifier, which is both good and bad because the further we get, the less chance we have of success. Now I'm switching over to DC now to check the output of the rectifier. Coming across these leads, and yeah, we're seeing 51 volts DC, and it looks stable. Do a quick and dirty test of the filter caps by measuring the AC ripple in that DC, switching over to AC, and coming across the rectifier here on test points 1 and 11. And yeah, there's like no ripple. There's no load, yeah, but there's no ripple either. So I'm not seeing any problems on that cap or those 3 caps, but I do want to test them anyway. We're going to do a bleed down. And if you're wondering why I'm not using my ESR meter, my meter doesn't support caps this big, even if I rip them out individually from the board. So what I'm going to do is I'm going to go and measure across the rectifier and the capacitor. And I just cut power right now, and you'll notice it had no effect on the voltage whatsoever. Of course, starting to drop slowly, but if this was 230 volts and you grab the caps after you shut it off, you get a hell of a shock. But we are seeing it is holding the voltage, and it is slowly dropping down. It's probably a high resistance resistor to ground somewhere in the circuit that allows it to bleed off very slowly once the power is cut. I believe this portion of the power supply, sadly, is not the problem. This IC here serves the primary functions of the switch mode power supply, and the capacitor that blew up was in direct service to this IC. It also looks like this IC's seen some trauma between D3. Due to the magical process of actually reading the datasheet, I gained some insight onto the functions of this IC. Immediately we find a 5.8 volt regulator tied to one of the pins that we could use to just check base functionality of this unit. And this will be bypass multifunction pin number 2. I'll point out that I've since put on a 0.1 microfarad capacitor here not knowing what the voltage was at the time, I now know that it is the DC voltage coming off the rectifier, but this one is 630 volts. It's not the correct value, but it's an abundance of caution. So I'll take my negative off the capacitor and go to pin 2. And sure enough, 5.77. My meter's not perfect, but this is definitely a good voltage. And I'm not running full AC voltage into this for testing. I think it's like 45 volts AC. Actually, on the capacitor here, we're looking at like 90 volts DC. So as minimal as needed. Seeing a slightly lowered but DC voltage on the drain. And I'm seeing 2 volts on the enable pin. There is an internal oscillator on this IC, as we see here. We should be seeing this on the output, 132 kilohertz. Now just for a minute, notice this red blinking LED on the other side of the board where the arrow's pointing. This will become relevant in just a moment. So I'm hooking shield to the negative of that capacitor, and I'm hooking my probe to the output on the IC. And we're seeing that DC voltage, and then it oscillates momentarily, and then it shuts off, and it's happening over and over. And that LED is flashing in time with this event. So I'm going to capture this on the digital scope. And sure enough, that's the frequency of our oscillator constantly resetting the output. And right here's a whole section on current limiting and overcurrent conditions showing the exact thing that we're seeing here. So if this is my capacitor in question, my capacitor could be wrong, causing this overcurrent condition. Or even worse, we could have a short upstream causing this problem. That'd be really bad. And I'm not sure that my capacitor I'm changing is in fact that capacitor. The board is multi-layered and I do the best I can based on the information provided in this datasheet. Excessive current is monitored from the output side of the coil through this optocoupler and various other components to cause the situation that we saw. So the question now is, what's causing the excessive current draw? If I have to go through and start checking ICs for shorts, I generally start with the ones connected to the big heatsink, for which I've also read the datasheet. But the only thing I'm really interested in are pins 22 and 23 off of our power supply. This is 15 volts and ground powering this IC. So power off, just checking resistance between the two, and 800 ohms. I don't know. I really don't know. Alarms are going off in my head right now. Checking with the power on, we see that LED blinking on the bottom and that fluctuating resetting voltage of 0.36 volts DC. I really don't want to start lifting stuff off of pads until I know what the right capacitance is, but I'm going to do it on this one. So I lifted this 15 volts out of circuit pin 23, 90 volts on the variac, and we're going with God. And there it is. And we have no longer this cycling condition. So it looks like this chip, after all, was pulling down the power supply, causing that overcurrent condition. It's also worth noting it looks like the protect circuit built into this device held its own. Serviceable and protected. Good job, Hayward. Reading the voltage off of that 15 volt rail with the chip disconnected, we now see, 16 volts, as there's nothing to pull it down. It's a little bit higher, but looking good. Looking at the output now of our tiny 274, we see an output that is consistent with a very light load as demonstrated in the documentation. But now it's time to reconnect our logic board. And we can see now reconnected back to the power supply, we should be receiving 12 volts right here. And there you go, 13 volts, as I would expect, slightly higher with no load on the system. Everything is working perfect now. So now I need to order a new integrated power module, and I really like to figure out what the actual value is for this capacitor. Obviously, I'm not going to be using this test capacitor. I'll find something more permanent. But until then, I'm going to cut the video here till my parts arrive. I hope you found this video enjoyable, entertaining, and informative. Do me a favor and hit that like button down below. Helps me out a lot when you do. And hit that subscribe button for more videos like this when they come out. When the next video in this series comes out, a link will be posted in the top right corner. I hope you enjoyed this video. Thanks for watching.
Thanks for watching. Would you like to reply?